Good day everyone. We are here to discuss about the formula on how to get the sum of all the natural numbers from a to n, wherein a is the first number and n is the last number. Before we proceed, let's define first the natural numbers. Natural numbers are the numbers that we usually count. They are positive integers or non-negative integers, which starts from 1 and ends at infinity. Numbers such as 1, 2, 3, 4, 5, and so on are the natural numbers. Let's try to answer this question. What is the sum of all the natural numbers from 1 to 10? Normally, to answer this, we can simply add 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9 and 10. By adding it manually, or by using a calculator, the answer will be 55. But what if the question is, what is the sum of all the natural numbers from 1 to 10,000? It's hard, right? Even if you have a calculator, it will be very tedious to add each numbers one by one. In school, we were taught about a formula wherein, to get the sum of the numbers starting from 1, up to the last number n, we need to add 1 to n, then multiply the result by n. And then, divide everything by 2. If you will substitute 10,000 as a value of n, you will get the result. The question is, do you know where this formula came from? Stay with me and let's discuss the method of deriving this type of formula. To derive that formula, let's set s as the sum of all the natural numbers from 1 to the last number n. At this point we will focus first in deriving a formula for a scenario wherein the first number is 1. Later on, we will discuss for another scenario wherein the first number is another variable not equal to 1. But for now, let's focus on this scenario. Since s is the sum of all the natural numbers from 1 to the last number n, we can write the equation as s equals 1 plus 2, plus 3, plus all the natural numbers until we reach the last number n. The number before n will be represented as n minus 1. And the number before that will be n minus 2. Let's set it as equation number 1. If you remember the commutative properties of addition, it states that changing the order of the numbers that we are adding will not change the sum. Thus, 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. Therefore, from equation 1, we can also say that s equals n plus n minus 1, plus n minus 2, plus all the natural numbers until we reach the first number 1. Let's set it as equation number 2. Now, let's take a look what will happen if we will add equation 1 and equation 2. Equation 1 plus equation 2. S plus s equals 2s. N plus 1 equals n plus 1. N minus 1 plus 2 is equal to n plus 1. N minus 2 plus 3 is also equal to n plus 1. As you may have noticed, adding all the terms will always result to n plus 1. If we will count the term n plus 1 in this equation, it is equivalent to the count of the natural numbers from 1 to n. The count of natural numbers from 1 to n is equivalent to n. Therefore, we can say that the term n plus 1 was added n times. Simplifying the equation, we can say that 2s is equal to the term n plus 1 multiplied by n. Solving for s, we will divide both sides of the equation by 2. Therefore, s is equal to the quantity n plus 1, multiplied by n, all over 2. And here is the formula. But take note that this formula is only applicable if the first number is 1. If the first number is not equal to 1, then we cannot directly apply this formula. For example, in this question, what is the sum of all the natural numbers from 125 to 10,015? We can still use this formula, however, we need first to calculate the sum of all the natural numbers from 1 to 124. Then subtract it from the sum of all the natural numbers from 1 to 10,015 to get the answer. Is there any formula that we can directly use for this kind of problem? Let's try to derive using the same method that we have used earlier. This time, a will be the first number. N will still be the last number. Again, let s be the sum of all the natural numbers from the first number a to the last number n. S will be equal to a plus 1, plus a plus 2, and so on until we reach the last number n. The number after a will be represented as a plus 1. And the number after that will be a plus 2. The number before n will still be represented as n minus 1. And the number before that will still be n minus 2. Let's set it as equation number 1. Again, by commutative properties of addition, we can also say that s equals n plus n minus 1, plus n minus 2, plus all the natural numbers until we reach the first number, which is a. Let's set it as equation number 2. Same as what we have done earlier, let's add equation 1 and equation 2. Equation 2, plus, equation 1. S plus S equals 2s. N plus A equals N plus A. N minus 1, plus A plus 1, is equal to N plus A. N minus 2, plus A plus 2 is also equal to N plus A. Again, adding all the terms will always result to N plus A. If we will count the term N plus A in this equation, it is equivalent to the count of the natural numbers from A to N. The count of natural numbers from A to N is equivalent to N minus A plus 1. Therefore, we can say that the term N plus A was added N minus A plus 1 times. Simplifying the equation, we can say that 2s is equal to the term N plus A multiplied by N minus A plus 1. Solving for s, we will divide both sides of the equation by 2. Therefore, s is equal to the quantity N plus A multiplied by N minus A plus 1, all over 2. And here is the generic formula to get the sum of all the natural numbers from the first number, A to the last number n. Going back to the problem that we have earlier. What is the sum of all the natural numbers from 125 to 10,015? Using the recently derived formula, let's substitute 125 as the value of A, and 10,015 as the value of n. Solving for this equation, we will know that the sum of all the natural numbers from 125 to 10,015 is equal to 50,147,370. Thank you for watching. I hope you learned something from this video. Please don't forget to click the like button, share, and subscribe to this channel. Appreciate it.